Hello. Today is my last stream before holiday break, so I decided to show something a bit more exotic. I am now installing Windows 3.11 onto my DOS box. Please forgive me that it is in Polish language. This is a copy of Windows 3.11 that came with my original DOS computer back in 1995. Yeah, my installer came on 3.5-inch floppies. Well, let's go with it quickly. You may have noticed on my previous streams that I like to use a very minimalistic set of tools. This is because I like to be able to come into another fresh machine, even perhaps a DOS machine or like machine with Windows 3.0 and be able to do something. So I'm used to managing to do my stuff with as few tools as possible, and usually my own tools like Phasm. The translation was really good. I would say that nowadays many translations are poor, but back then, when there was a translation, it was really good. I need to restart DOSBox. Let's clean up a little. Yes, program is the same in Polish as in English. Now we have a minimalistic, just freshly installed Windows 3.11. And what can we do here with our tools? Well, this is 16-bit Windows, so 32-bit PE programs are not going to work. you can see screen flashing a bit when I try to run a PE executable. It is Windows 16-bit Windows does not know yet a PE format, so it only sees stub, mz stub of such executable, and it runs the stub. If we try to run a PE example, the same would happen. It blinks too quickly for us to see the message that the stub displays. This program cannot be run in DOS mode. On the other hand, FASMD works. But FASMD requires DPMI, 32-bit DPMI. And Windows 3 provides 32-bit DPMI. Windows 3 is based on Windows 3.86 kernel, in this case. And it has full implementation of 32-bit DPMI that FASM is able to use. Now there is something curious about DPMI even in Windows 3 that was kept for all future Windows versions. It is that Windows implements DPMI 0.9 and it never implemented DPMI 1.0 standard. But it did implement something that some people call true DPMI. Something that DPMI was initially supposed to be, but officially never became it. So there is this huge area of undocumented DPMI standard, and Windows was among many implementations that have this undocumented standard. I think I can demonstrate it here. There is this old example that comes with FASM of program that uses DPMI. We switch to protected mode, set up some segments. Let's compile and run it. It displays a message. It uses a function 2 of DOS interrupt to display a single character in a loop. This is because if we wanted to use a function like 9 that passes the pointer to string, the pointer would be lost when switching modes. While this function that only displays a single character does not use pointers, so the values are preserved when switching to 16-bit mode to DOS, and it works. Now, what true DPMI is about is that it provided 32 versions of entire DOS interface, all DOS functions. So we could use function 9 with true DPMI. And just provide a 32-bit pointer. As you might recall from when we were writing DOS programs on a stream a few days ago, this string needs to be terminated with $. Alright, let's run it. Let's modify a message a bit. Yeah, I can write it as 2.4 like last time. Doesn't matter much. As you can see, Windows 3 provides true DPMI interface. We have a true 32-bit DOS here. Even though Windows is 16-bit, but Windows 3 has 32-bit DOS under the hood. And now, what I wanted to show you is this peculiar extension to Windows 3 called Win32s. S stands for subset. This is a subset of Win32 API available for Windows 3. And this now should add a support for PE executables into Windows 3. Do we want to install FreeCell? This was a game that was written to demonstrate Win32 back in the day. Alright, let's install it. Yeah, it works. But I'm not going to play right now. I want to try to run my own PE executables. This time it works. What about FASMG then? Oops. This does not look good. You see, let's take a look at the sources of our PE demo. It has this very important line here. As you can see, back when I was preparing to distribute this example with FASM, I added this comment. Win32s is not able to run PE that has no fixes. Apparently. It needs relocations. Let's try it. Let's see if we can assemble FASMG here. Oh, we need the includes Windows headers. Fortunately, I have copied them here. I just need to provide the path. Yes, this should be okay. Great, we are able to assemble FastMG. Let's add some relocations to it. We should just copy this line. Well, for some reason, Shift with arrows does not work correctly under Windows 3 in my editor. Oh, but Shift plus Control works. We can paste it here. And now assemble FastMG with relocations. Does it work now? Oh, not this one. I assembled it in here. Alright, it works, but it does nothing. You see, Windows 32s does not have console. So PE marked as console, this flag is ignored. It's treated the same as PE for UI. Graphical UI. We can test it some other way, perhaps. Let's copy it to the usual place. Replace. Alright. And now let's run the command. No source. Output. And perhaps some command. DB instruction. Yay, we have our file. Oh, we cannot view it so easily. Let's try a different extension then. Everything works. So we can use FastMG here. That's great, because I have copied some sources from my PE tutorial that uses FastMG. And we can now assemble them and do some experiments. Well, this might be slightly tedious. Perhaps we can copy the command. Yeah, we can do it this way. You see, this is what I meant when I mentioned that I like to be able to manage in any environment with just the tools that the system provides. Oh, let's take a look at the source. It has no relocations, so it won't run. But we can try it once more just to show it. Also, we may add this so that we do not have to specify output name. Alright, we have it. Oh well, it does nothing. Oh, I normally would even run programs from FastD just as I compile them. But here, when we are in FastD, we are in the DOS subsystem, and when we run PE executable, it just runs the stub. And now I'm even using FastG instead of FASM to assemble my examples. I'm not sure yet why the basic PE was behaving the way it behaves. We may find out later. This one has relocations, so it should work better. Yeah, this one works great. So, now the question that comes to my mind is, Win32s for some reason requires relocations. Therefore, the default base that we provide probably could not be used. So what is the address that Windows 32s can load the image at? And we may find out by displaying it with our program. So let's modify this program so that it displays its own address. We need a writable data segment for this. First, we need to extract our own address somehow. But since this source is designed such it generates relocations automatically, we can just use relocated address. The other way to do it would be to just use call. And then edx would contain address of next label. Now we need to convert it to hex. Which method should we use? XLAT table or Ellison's algorithm? And here we need our conversion to hex digit. Does that look okay? Oh, because there is no console, we cannot even see error messages from FastMG. But it works. Oh, lack of space after comma? Well, you may be right. A source could perhaps be even cleaner, more readable with that additional space. It's just I got used to this standard of writing assembly back in the day, and you know, old habits. Yes, this is what is interesting here. Win32s loads PE at such high address. Normally Windows would not load at such high address unless you have a flag large address aware. But this was back in the day when there wasn't even such a flag back in the day. So if Win32s needs to load our program at such a high address, then it is understandable why it could not load with our default base, which is low. So let's do an experiment and use this high base as our default base and use no relocations. Would it work then? It was 8844 and 4 zeros. Oh, thank you for appreciating my topics choice. I thought it would be a fine topic for my last stream before holidays, because it is a bit bizarre topic perhaps. So old system. You can rarely see 16-bit Windows nowadays. And Win32s, wow, that is exotic really. It works without relocations. So you see, it was not true in my source when I wrote that relocations are needed for Win32s. You can run without relocations when you use a high default base. Contrary to what all other versions of Windows do, Win32s uses very high bases for PE images, and it does not know any other way. It is gobsmacking. I don't even know that word. Is it Australian or more general? Oh yes, you're probably right. I think that the lower half is used by regular Windows 3.11 here, 16-bit Windows. So they had to use the high address space for 32-bit ones. Okay, so we got PE without relocations running on Win32s. This is what I wanted to show you today. What is interesting is if we don't close this program and try to run another one, well, then it fails. Of course, it has no relocations and tries to use the same address. What it tells us is, no, well, I already knew that there is just a single addressing space for Windows 3.11. All programs share the same addressing space, so when we used this address to load a single copy of this program, we cannot load a second one, since the address is already taken. But when we have relocations, then this is not a problem. Oh, you see, it found another address for second copy. Yet another one for third one. Well, that's all I wanted to show you today. Thank you for watching. Well, if you would like me to answer any additional questions or do something more, then please ask. What year was it? The computer that this Windows was for, I had in 1995. But Windows 95 was not out yet. I don't remember, was Windows 95 out in year 95 at all, or was it 96? Yes, when I was writing FastMG, I was considering that I would like it to run on older machines too. That's why I don't use fancy stuff like SSE or 64 bits there. It is just basic 32-bit instructions. Yeah, FASM1, at least it's DOS version, but Windows version perhaps too. It looks at how much memory computer has and tries to use all of it. When you specify requested memory with a switch, FASM tries to allocate that much, but it would fail on such an old system, and FASM would allocate as much as it can, but not the full requested amount. Well, I think you could assemble large projects. I don't know if Win32s has some memory limitations. I believe that if you had enough RAM in your computer, then Win32s would be able to use it all. Well, FASM does not require any... FASM1, not FASMB, does not require system to manage memory in any sophisticated way. It just needs to allocate all that memory in a single huge block and it can use it. Yeah, okay. I'm going to be back in January. So we now have a holiday break for 2 weeks perhaps or so. And I'm probably going to go back to more usable in modern world topics. The one for today was just something that I find fascinating, but it's not of much of use today. Oh yeah, I plan to cover some Linux ELF stuff. I have not yet decided how to stream this. I could just use Linux over SSH terminal. Or perhaps a virtual machine. Thank you everyone, and see you next year.